Hello there, welcome again. In this lecture, let's talk about floating point literals. So far, we said that a literal is a fixed value that is directly specified in the application source code and is used to initialize variables. For example, here, the pi number in these variables is a floating point literal. In the first one, the f suffix determines that the 3.14 is a float literal value. And here, the d suffix determines that this number is a double literal value. And finally, the m suffix determines that the 3.14 is a decimal literal value. Okay, in these examples, the type of these variables is declared explicitly. But if we have an implicit variable, how this literal value is interpreted by the compiler? As you know from the previous lecture, any decimal value without a suffix or with the d suffix is interpreted as double, and with the f suffix is interpreted as float, and with the m suffix is interpreted as decimal. The examples we've shown you so far are the most common way to represent a floating point literal, like these examples that you're seeing now. They consist of a sequence of digits, optionally followed by a decimal point and followed by another sequence of digits. And at the end of the value for float and decimal types, we have to use a suffix, but in the double type, using the d suffix is optional. In C#, these are called decimal notations. Also, you should to know that when a literal value is very large like this one or very small like this one, we can use scientific notation. It consists of a mantissa followed by the uppercase E or lowercase e, then followed by an exponent. And as you can see, the mantissa and exponent are separated by the lowercase or uppercase e. Alright. The double variables as well as the decimal variables may be expressed differently, but they have equal values. To confirm that, let's illustrate to you how they are equals. First, you need to know that the e in the scientific notation stands for times 10 to power of. So, the 9e plus 18 means 9 times 10 to power of 18. And this number can be written as this number. So, as you can see, these two numbers are equal. And in the decimal examples, these numbers means 1.23 times 10 to power of minus 4. And this number can be written as this number, so these two numbers are equal as well. Alright, let's head over into VS Code and show you some examples. Okay, let's say var my number equals 3.14. As you can see, the literal value is interpreted as double type. Also, if we put the d suffix, the variable type is still considered double. So, as you notice, the d suffix is optional. Also, you should to know that this number has been determined by the compiler as double type because of the decimal point. So, if we clear out the decimal point, the number is determined as an int type. Because, as you know, any integral number without a suffix is interpreted as an int type. Now, can you guess how to determine this number as double without using a decimal point? Okay, to determine a number as double without using the decimal point, we can use the d suffix. Also, we can use the f suffix for float types and the m suffix for decimal types. Alright, Now let's show you some examples of the scientific notation. So let's say decimal, my decimal equals 9e2m. Now let's use the write line method to print the my decimal number in the terminal. Save the file and try it out. As you can see, our actual number based on the scientific notation is 900. Now let's change the literal value. Let's say 9 and 18 0. Save the file and test it out. As you can see, our number is a very large number and can be difficult to read, so it's been displayed in scientific notation to make it more readable and easier to work with. Alright, done. See you in the next lecture.